not used much. What we use most now is binary, decimal, and hex. Hexadecimal is actually the same thing. As far as the NA stage is concerned, the most important thing is the conversion between binary and decimal. If you usually write a decimal, you're not sure how much. You can check it here. For example, we write a 192. Binary is 11000000. For example, write another 168. Binary is 10100000. Finally write a 111. Binary is 01101111. This is a calculator. Today we're going to talk about subnet masks. There is also a calculator for the subnet mask. Specifically to calculate it. We can see it later. So let's go back to that question. If the 32-bit binary is expressed as a decimal IP address, what is the maximum address that can be expressed? And what is the minimum address that can be expressed? Okay. For 255s and 40s. That is, for 32-bit. If all 32 bits are set to 0, must be the smallest value. That is, for IP addresses, current max and min. It's actually pretty well calculated. The smallest representation is all variable binary. Are set to 0. Actually 32 zeros. Every bit is 0. 0.0.0.0. The largest representation is all variable binary. Are set to 1. So what is the result of my calculation? The result is to add from 128 to 1. Is 255. Remember this number. 255.255.255.255. That is one of the 32 bits of the final expression, written in dotted decimal, is 4255. You should know these two. This is what we call max and min. Everyone will find. Since IP addresses have a maximum, have a minimal. That's actually 40 to 4255. This is the overall range of IP addresses. Then I will give you a simple question. Let's do the math. And this question, it is also related to the content of the next part. Let's take a look. 11000000. This is the first. 11100000. Then 11110000. 1 at the end 11110000. Now it's a binary. Let's calculate the corresponding relationship in decimal. Just add the first 2. Add the first 3. Add the first 4 bits. Add the first 5 digits. So let's do a quick calculation. 192.224.240.248. First of all, it must be correct. I want to ask you a question now. Is this an IPv4 address? Do you think this is a bit strange? I believe that it is difficult for everyone to see addresses in this format. Most of the students think it is not an IPv4 address. For our IP address, no matter how strange it looks, but it only needs to conform to the configuration format of the IP address. It is a correct IPv4 address. It is in the interval. And everyone is. It also does conform to the config format. So it's an IPv4 address. But you have to think about one more question. That means we are in the network. Can the IP address be assigned at will? We all know. Devices that want to communicate must have an IP. Then this IP is not as much as you want. It is indeed an IP address. But it is not particularly in line with our configuration habits. So what are our usual configuration habits? For IP addresses, there is a standardized organization in the world. is dedicated to managing and assigning IP addresses. This organization is called IANA. It is an allocating authority for Internet addresses. It divides the entire IP address into 5 categories. Including your future study of IPv6 is also managed by this organization. Let's briefly summarize. Divided into 5 categories of ABCDE. Let's start with the first one. Class A address. For Class A addresses, 32 bits in total. Usually 32 bits are divided into 4 octets. We must first notice. First bit of first octet must be 0. That is, the first digit of 32 bits must be 0. I don't care what's behind. This format actually restricts only the first. It doesn't matter what happens after. The first bit must be set to 0. So now there is a new problem. If now the first digit of an address set to 0. So what is the current address? How big is the largest? How small is the smallest? First of all, how small is the smallest? The first value is 0. Then the last 31 are all 0. That is, minimum is 0.0.0.0. So what is the maximum? Okay. The maximum is from 127. Everybody can count. Since all values are now 1. Is 255. That first one represents 128. In fact, the maximum is the sum of the last 7 digits. There is no restriction on the number of digits in the rear. The last 31 digits are all 1s. Except for the first octet special. The back is 255. So in fact, the range it expresses is 4255. That is, 3 255s are preceded by a 127. This is a range of it. So you will find Class A addresses actually define an interval range. Okay. We next look at Class B addresses. Class B addresses are actually similar to Class A addresses. It specifies the first 2 bits of the first octet must be 10. The minimum format is 128. The smallest is actually the first value of 1. The rest are all 0. The first value of 1 is 128. The last 7 digits are all 0. No value. Then the maximum is 255 minus 64. Is 191. Okay. Although no one has calculated the answer. But we all know how. In the end, this value is not the most important. We know what counts that counts. The above are Class B addresses. Let's move on to Class C addresses. For Class C, in fact it will have some of the same places. It specifies the first 3 bits of the first octet must be 110. So they are actually connected to each other. The minimum format of this format is that the first 2 digits are 11. Then everything after that is 0. That is, 250 minus 32 is 192. The biggest is 110 followed by 5 1s. Okay. Is 223. We have finished the ABC class addresses above. Actually, we're already halfway there. Let's stop. Let's not talk about Class D addresses. Because Class D is actually the same format. ABC 3 types of addresses we call them. Unicast address. For equipment, there are only 3 types of addresses in ABC. It can be configured on the interface of the device. Do you remember what unicast is? I mentioned some in the last lesson. When we communicate one-on-one, like the second floor, we are going to do data encapsulation. Then package. Layer 2 encapsulates source MAC and destination MAC. Layer 3 encapsulates source IP and destination IP. Then one device communicates with another device. We call it unicast. Only the three types of addresses ABC are called unicast addresses. It can be configured on the interface of the device. Or for terminal. Configured on the device's network card for identification. For equipment. When you go to address configuration, all configured addresses are ABC class 3. This is called a unicast address. The remaining two categories are different from them. We mentioned it last class. Except for unicast. Also broadcast and multicast. Let's talk about multicast first. We didn't go into great detail before. Because at this stage we don't need to understand the whole multicast. This belongs to the knowledge of IE. I told you about the format of the MAC address before. A MAC address is a 48-bit binary number. We want to measure whether a MAC address is unicast or multicast. Depends on whether its 8th bit is 0 or 1. Then everyone should know. For the network layer, there is also a special segment in the IPv4 address for multicast services. So let's learn about Class D addresses now. Class D address. It looks from the format same as the others. Because it specifies the first 4 bits of the first octet. Must be 1110. So it doesn't actually change much in the format. Then its smallest representation is 224. The biggest thing is all 32 bits except the 4th bit are 1. That is 239. This is the range of Class D addresses. But only when you learn IE. Access to the real multicast service will only come into contact with Class D addresses. Then for a Class D address, it also has its own characteristics. It has a very clear stipulation. A Class D address can only exist as a logical address. It cannot be configured as a real address. But only in logic. It cannot be configured on the interface of our device. We all know. The device interface needs to carry out 3-layer communication. Is to configure the IP address. The assigned address cannot be a Class D address. You can understand a logical address as a virtual address. Let's say we're going to send data. Can be sent to a virtual address. And other devices can receive information about this virtual address. We call it listening. But this address, it can't be paired with any one device. Everyone can understand. It is a logical address generated by simulation. Configuration is not allowed. Multicast is knowledge belonging to IE. Slightly harder. We can't get in touch at the moment. So we are actually the most important now is the first 3 categories. ABC class. That is unicast address. This is what we will configure in the future. The last one is a Class E address. For Class E addresses, it also has its own corresponding regulations. It specifies the first 4 bits of the first octet. Must be 1111. Its minimum is 240. The maximum is that all values are 1. Actually 4255. So you will find the minimum of Class A is 40S. The maximum of E is 4255. That actually divides the ABCDE 5 categories. Our address range is from 40s to 4255s. Class E addresses are also special. It is a reserved address. The reserved address we call the laboratory. It is used for military or scientific research to do some research. This address is sealed. Temporarily unavailable to anyone. We can now use only the above ABC 3 categories. That is to say, what can really be configured are the 3 of them. Class D addresses we can also use. But it will involve some applications and protocols. When adding groups in the future, different protocols use different multicast addresses, including different applications. The logical multicast addresses they use are also different. A dynamic routing protocol will be learned in NA. called OSPF. At this stage, a multicast address will be touched. R225.0.0.5 and 6. That's not our focus right now. In fact, everyone knows that OSPF will use multicast. We have now introduced 5 categories. Class E addresses are reserved. You can't use it. But we can use the ABC class address. Please pay attention. Although Class ABC addresses can be used, but not all addresses of the ABC class can be used. There are some special ones that cannot be used.